I'd like to welcome everybody here for something that's going to be quite interesting, quite exciting. I've been looking forward to it for a while, particularly since I just read a piece in the New York Times that talked about the fact that porpoises recognize themselves in mirrors before at a younger age than human babies. So that begins to get you thinking about all these kind of aspects of the human mind. And so looking forward to hearing much about it. And we'll turn it over to Matt Grobe.
Thank you, Erwin. Thank you so much. Wow, you know, we're all in for a real treat tonight. The topic of artificial intelligence and how far we can go with the machines we're building and what levels of function they will attain is super relevant. You can't not read about it almost every day in the news. So it's going to be quite a treat. I thought I'd take just a minute to tell you the interesting story about how this event came about. A couple of months ago, I was fortunate enough to be invited to an event for the Penrose Institute, and invited Eugene, and they met. And then then Paul Jacobs and I were visited Eugene at Brain Corporation. I'll tell you a bit about Brain Corporation in a second. And Eugene was explaining his views on artificial intelligence and how far we could go. And his views contrasted with those of Roger. And I said to Eugene, you know, I'd love to hear you say this with Roger in the room. And then Paul immediately said, yeah, me too. In fact, I'll host a dinner at my house so we can have this debate. So I thought about that. That was pretty interesting. Wouldn't that be cool? And I asked Eugene later, would you really consider doing that? And he said, yes, I would. And I talked to James, and he mailed Roger, and I got an answer back very quickly. Yes, I would. And not only that, Roger was willing to come immediately to San Diego even last year before the break to have this out. So then I thought, okay. So then I talked to Paul. I said, Paul, so were you serious? Did you really want to do that? And he said, yeah. And it started to snowball, and there were a lot of excitement. And it grew a little bit. And then Paul said, you know, we're getting remodeling. We got the baby. Maybe it's too big. We should get Erwin. Erwin wants to do it. So I mailed Erwin, and I talked to Joan at that IEEE event. And the answer was yes, enthusiastic, let's do it, which is why one of the many reasons we love Joan and Erwin so much. They have enthusiasm to do these kinds of things. Yes. So we set about planning it, and there was lots of choices on format and what the topics, and fascinating email threads that I will treasure back and forth on how to do this. But I think you're in for a real treat. So let me just give you a brief introduction. On my left, we have representatives from Brain Corporation. So Eugene is a good friend, and you know, he's the CEO and founder of Brain Corporation. And it's a company that was kind of, in some sense, incubated by Qualcomm. They were inside our building at Qualcomm Research Center. Prior to that, Eugene was a fellow at the Neuroscience Institute. And more than 10 years ago, he created a simulation that had a trillion neurons and a quadrillion synapses. So both of those figures are on the order of the same numbers that a human brain has. He's a pioneer of spike timing architecture for artificial or neuromorphic hardware. We built machines based on that were able to learn and do interesting things. And more recently, his company is making these fantastic robots. That's one of their first products. They're autonomous vehicles that can drive around, and they can clean the floors of big commercial buildings like retail stores, Walmart, Target. It ran at the airport, it ran at Lowe's. They can run with people in their way and make decisions and so forth. And last year, they had a great year. They raised over $100 million from the Masayoshi Son and the Millennium Fund. And I think that's, if I'm not mistaken, they raised more than any other robotics company in the world last year. And so it's just a real exciting story. So Oleg is one of Eugene's team members. He's an expert in AI and deep learning, and particularly the application of artificial intelligence to robotics. He's one of the architects of the Brain OS, which is the platform that they use for their products. And I learned, to my delight, Oleg has read all of Roger's publications on consciousness. So,
Well, not all.
okay, so that's on my left. Now, on my right, Roger really needs no introduction. I will humbly try to just say a few words. Roger's a mathematician, a mathematical physicist, a cosmologist. He's a fellow at Oxford, very well-known author. You see his videos, his books, his famous book, The Emperor's New Mind, which I think was in 1989, which actually addresses a number of the topics that we're going to talk about tonight, and there's a whole series of those. So we're very grateful, Roger, that you have traveled from the UK to be here tonight for this event. Thank you so much. And James Tague is an entrepreneur and a scientist and an inventor and an author, and he's one of the co-founders of the Penrose Institute, which is newly formed, has sort of headquarters or location both in London and here in San Diego, and seeks to study consciousness and artificial intelligence and the relationship between consciousness and the fabric of the universe. So absolutely fascinating. James also, being an author, wrote a book, Are the Androids Dreaming Yet? And for those of you who are into science fiction, that title has a kind of a special meaning, and it's an excellent book. So now, last thing before we start, I wanted to we're not going to have enough time to really go through all this because it would take like a year. If you want another dose, Roger is giving a talk tomorrow at UCSD at 3 p.m. on a slightly different topic, dark matter, but I wanted everyone to know that. Okay, so then to frame the discussion, before this, we mailed back and forth a lot of interesting points and kind of came up with 3 formative questions. And the first question has to do with the simulation of neurons. So if you think of a computer or a brain as a computer of neurons, the question is, if you can simulate a neuron and you have enough of them and you connect them with the right architecture, can you actually create a brain that has the capability of consciousness or conscious learning? So that is a question. And is it possible with like digital logic as long as you have enough? Or do you need to go deeper to more subtle effects? Do you need to consider quantum mechanics in order to do that? So that's the first question. The second question is biology the only path to get to consciousness? We know biological organisms can do it, and can we mimic that? Can we come out about it with a technology that's artificial and still achieve consciousness? And the third question is, if we could do this, could we do it, could we connect it over distance? So could you have like consciousness here and provide it there via radio or quantum entanglement or some technique like that? Could you convey? And if you could, what would the ethics of that be? What would the impact on society? So those are kind of formative questions. And each side is going to talk, give you some opening comments. Then we'll go back and forth for a while. And then we're going to have time for audience questions and answers. And we're going to wrap up at around 7:30, 7:40, and then finish the evening with some mixing, and you'll have a chance to meet everyone and talk. So that's the format. And without any further comments, let's start with Eugene Hitskevich.
Thank you, Matt. I'm really humbled to be in the company of Roger Penrose. Not because when I was undergrad, I was studying Penrose theorem, only using Penrose inverse matrices, and I heard about Penrose styling. But I'm a big fan of Escher, the painter. And I didn't know at that time that actually Escher was inspired by Roger. In fact, some of the paintings, like the infinite staircase, it's called Penrose staircase. The triangle is called Penrose triangle. So Roger humbly will acknowledge that no, he was first inspired by Escher, by the tiling, but Escher and his memoirs actually acknowledged Roger Penrose. So this is something that was not written in the brochure that we distributed, but it's something that I want to know that this is really a special moment for all of us, and for me in particular, just to be in the presence of Roger. And this makes me really, really, I have to be really careful how we have this debate, and debate assumes we have difference in opinions. And I will start with my opinion. My introduction is that I want to quote Peter Thiel, the founder of PayPal and first investor into Facebook, who said that science fiction writers promised us robots and flying cars, and instead we got 140 characters. Where are those robots? People, they all promised to us, right? Like, we're supposed to be here 50 years ago, and they're not here. What happened? And what we quickly realized at Brain Corporation, while we're still at Qualcomm campus, is that all those robots of the future already exist today in the form of manual machines. They all require people to operate. Those robots made by hundreds or thousands of companies. They have many, many users, but each and single one needs a human brain to steer, to push, to pull, to operate it. What we're doing at Brain Corporation, we're building brains for those robots. So the robots that Matt mentioned, we didn't build them. Those are standard machines. We put our brain inside. So my entire career was devoted to studying brains. First, up until 2009, I'm a recovering academician, studying brains at the Neurosciences Institute. I'm a mathematician, but I was building large-scale models of mammalian brain. And then the last 8 years with running Brain Corporation, building artificial brains. And here, and I was thinking, how can I possibly argue with Roger? And then I realized that, wait a second, at the Neurosciences Institute, which was run by Gerald Edelman. Gerald Edelman received Nobel Prize in early age for explaining how the immune system worked, and then he spent the rest of his career trying to understand consciousness. We have this debate every weekday. For the last 9 years, when I was at the Institute, we had this debate with Edelman every year, including theories by Roger Penrose, other theories. And then when I moved to the Institute, I grew up for 6 months with Giulio Tononi, who one of the leading experts in consciousness. In fact, I took his office. I spent 8.5 years in his office. I also worked closely with Bernie Bars, who developed global workspace theory of consciousness. And it was Bernie Bars and Giulio Tononi who convinced me that consciousness is a real scientific subject. I was afraid of this topic before joining the Neuroscience Institute. I remember that every neuroscientist tells you that if you're a professor at the neuroscience department, there are 2 words you should never mention before you get in tenure: consciousness and free wills. Okay, there are 3 words. And I thought it's something spooky until I start working in the institute, and then I just amazing researchers and scientists there convinced me this is a topic worth pursuing. So we have a lot of arguments. And some of the arguments were about theory of consciousness and Roger's theory of whether a relationship between consciousness and quantum physics. So, and here just, I would like to point at certain aspect of Roger's work, in addition to his contributions to mathematics, to cosmology, to art, is that he wrote a number of books, like the one, The Emperor's New Mind, is one that attract a lot of bright scientists from the fringe of AI to AI. This is one of the biggest contributions in my mind of Roger, just is that basically by this book and by a number of publications and TV and by being such an eloquent speaker and being such a promoter of this topic, he recruited hundreds of thousands, maybe millions of people who right now study either neuroscience or doing engineering, doing deep learning. Like, here's one example, chief scientist of Brain Corporation. The reason he's here, one of the reasons is that, that he was mesmerized by Roger's work. So this is and I'd like to thank Roger for bringing this whole community of young people into this field of AI and computational neuroscience. But there's a drawback to this, because the way Roger presented his theories is that he connected them to quantum physics. And in this case, it's, some of his theories were deeply misunderstood. And people will say that, look, quantum physics is mysterious, consciousness is mysterious, they must be connected. or I don't understand quantum physics, I don't understand consciousness, they must be connected. And this is huge disservice to Roger and his theories. So what I would like to have today is actually to give Roger kind of a way to explain his theories and kind of look at them from a point of view that how can we apply this to build smarter machines. Talking about smarter machines, we can talk about consciousness, but let's talk about intelligence. What's intelligence? What's the definition of intelligence? We have definition of information and entropy, but how do you define intelligence? And do you need to be conscious to be intelligent? Is my calculator intelligent? Is my cell phone intelligent?
It is.
It is. Oh, this is why it's called smartphone. So, can we build intelligent robots? This is the mission of Brain Corporation, builds brains for robots, so robots are intelligent. Is Roomba intelligent? Some feel it's yes. Could it be other types of robots which are intelligent? So this is what we're striving to do, but we don't even have definition of intelligence. How you define intelligence? How you measure intelligence? We can measure information, but we cannot measure intelligence. And this is the topic that is very close to my heart. But then Roger goes beyond that. Says, okay, let's define consciousness. Let's give a definition. Let's talk about consciousness. And what do you need for consciousness? And this is very important for us because once we build intelligent machines or intelligent algorithms, and today we have algorithms which surpass human intelligence in many aspects. I'm not talking about multiplying numbers. I'm talking about playing chess, playing Go, recognizing faces, recognizing digits, recognizing speech, human speech. Today's algorithms can do it better than humans, recognizing human speech. So every aspect of human intelligence that you can imagine, if it has any application to business or any application to any practical application, the algorithms already surpassed it or will surpass it next year. So pretty soon we'll have robots which will look intelligent, behave intelligently. Are they conscious? Do they have consciousness? How you verify that? Can you ask robot, are you conscious? Oleg and I, just as a joke, asked Siri, are you conscious? She said, yes. Do you believe it? Is Siri conscious? And what kind of problems we'll have? Do we want conscious machines? Maybe we don't. Maybe we want intelligent machines, but not conscious machines. Maybe we want to prevent this from happening. And if you have a conscious machine, can you turn it off? Is it okay to kill a robot, a conscious robot? Many people watched Westworld, which has a lot of ethical issues. Google right now, and actually every company doing self-driving cars is facing this issue, that ethical issue. What do you do? How you program behavior of the robot such that it minimizes the harm to humans? So if you have conscious robots, then it comes in verse, are we going to harm those robots? And what is the definition of consciousness? And what is the path for us to build it and simulate it? Can we even simulate it? Can we simulate it in a digital computer? So here Roger and I have opponent points of view. I'm a big believer that the consciousness, intelligent consciousness, doesn't require quantum physics, doesn't require any special explanation going very, very deep. We still miss this definition. Right now we're in a stage where information theory was before Claude Shannon. Imagine this conversation about information 100 years ago. Do you need humans to transmit information? What's information? How can you measure it? What if is it Morse code? Is it information or not? If I tell you that right now is 7:15, is it information? So that just imagine how confused people were before Claude Shannon. We are equally confused right now about consciousness because we don't have a definition. And in fact, I can say that the opposite. There are more definitions than the number of researchers in the field of consciousness. Everybody has his own or her own definition. And this is something that I would like to bring this debate, and I would like Roger to present his theory, his point of view, and how he thinks it must be related to quantum physics. And then maybe debate about, okay, do we have any hope of building conscious machines? Do we need to understand quantum physics all the way to detail? Or can we abstract from that? Can artificial systems be conscious? So this brings excitement to me just because this reminds me of my best years of my academic career at the Neuroscience Institute, when we have these debates every single day.
Thank you, Eugene. Very well said. Sir Roger.
Well, it's very nice to hear what Eugene is saying, and I appreciate his references to what I've been doing. I should explain, I have a certain point of view which is described in my book, The Emperor's New Mind, which I think was published in 1989. There are a lot of things which have moved forward since that book, and one of the main things that's moved forward I'll come to shortly, which had to do with... So I wrote the book because I wanted to express a point of view which I hadn't seen expressed anywhere else. The point of view arose, I think, when I was a graduate student, which was quite a long time ago, in the 50s. And I think I was as much a computationalist as anybody, thinking that computers at those stages, of course, Turing had established what a general purpose computer was and all that. And it's not an unnatural view to think that any physical object in the world is something which satisfies laws of physics, and that those laws are things which you could simulate computationally. So that view was certainly something I held at that time. There were a couple of things. I went to lectures which were absolutely nothing to do, I thought, with the work I was doing, which was a topic in algebraic geometry, pure mathematics. And, but as a sort of side thing, thinking I had 3 years to do my research, so I don't have to worry too much about which lectures I go to. And I went to lectures on topics that interested me and which didn't seem to have anything to do with what I was doing. One of them was a course on mathematical logic, and I learned about Turing machines, basically the idea behind a general purpose computer, as we understand today, and Gödel's theorem, which is something that has sort of worried me. I hadn't understood it before, because it seemed to tell you that there were things in mathematics that we couldn't prove, and that disturbed me. What I learned from this course was it wasn't like that at all. There are things, let me explain about Gödel's theorem, because it had a big impact on my views later on. I'll come back to that in a minute. I went to a course by Dirac on quantum mechanics, Dirac was a famous person who actually set forward the laws of quantum mechanics. He did, and John von Neumann. But he also put forward the equation for the electron, and sort of an amazing man. But I remember his first lecture. Let me say this because it's important later on. In his first lecture, he had a piece of chalk, and I think he broke it in two. He was talking about the superposition principle in quantum mechanics, which says more or less if A can happen and if B could happen, then according to quantum mechanics, you can have A and B in any combination, so much of A and so much of B, and the state could be that as well. So what about this piece of chalk? It could be over here, or it could be over here, and in that kind of superposition. And then my mind sort of wandered for a bit. And then he said something, I didn't hear what it was, which was the explanation why a piece of chalk couldn't be in two places at once. And I heard him say something about energy, and I was so puzzled by what he'd said, I never dared to ask anybody because I didn't want to confess that I'd sort of dozed off from that point in his talk. But I meant sort of worried about that ever since. Why is it that a piece of chalk couldn't be here and here at the same time as quantum mechanics says it must be? And so that was the thing that puzzled me. So I had these various things that puzzled me. Let me go back to Gödel's theorem. Now the thing there, what did Gödel actually say? He didn't say that things can't be proved. He said if you have a certain set of procedures, he didn't quite put it this way, because Turing came after Gödel, but let me put it in Turing's way. If you have a set of rules that you could put on a computer to say whether you have applied those rules correctly or not, and these are rules to prove certain things in mathematics, let's say things about numbers. Now, you have to believe that those rules, if you're going to use those rules, you have to believe that if you use the rules correctly, and they say, yes, this is true, you have to believe it is true. That is to say, you have to trust the rules as only giving you truths. And the amazing thing that Gödel showed is whatever those rules are, you can present a statement which you could see must be true on the basis of your trust in those rules. but yet which you cannot obtain using the rules. So the use of those rules does not give you this statement. However, your trust, your belief in the rules, your knowledge that using those rules actually gives you truths, will tell you that that thing is true. So what he doesn't show is that there are things that you can't establish in mathematics. What he does show is that if you base your belief in what is true and what is not true on computable rules, then you miss things. There are things that you cannot obtain by those rules, but yet you still know must be true. And that was something which just hit me in whatever it is where things hit you. And it sort of stayed with me for a long time. And I formed a view at that time, long before I wrote The Emperor's New Mind, which is that there must be something in our conscious understanding. You see, how do you know that these things in mathematics are true or not? There must be something in our understanding which is not computational. And I tried to think, how could that be? Because I was as much a materialist, I suppose you can use a word like that, as anybody else. And I believe that however our brains work, it must be according to the laws of physics. And if it's according to the law of physics, well, Newtonian mechanics, you could imagine putting it on. There's a slight problem there because the laws of physics depend on continuous parameters, whereas computers depend on discrete numbers. Well, maybe you can approximate things as well. It didn't seem to me that was a big objection. There was a little bit of a problem there, but let's forget it because I don't think that's the crux of it. Now, the thing is, if our brains operate according to these laws of physics, and you could put those laws of physics on a computer, then our brains must be acting computationally, and therefore, why aren't we subject to this Gödel problem? Well, it's a little more subtle than all that, and you have to, in my book, I had to go into this. And then the argument I put in The Emperor's New Mind, I thought people didn't understand because they objected to things which clearly meant they didn't read the book. And so I decided to write another book, which was Shadows of the Mind, where I put in all the different things, queries, this thing could be wrong, this could be wrong, this could be wrong, this could be wrong, and I answered them all. The trouble is that people didn't read that book either. And so I feel that it didn't really help too much. But it convinced me that there was something going on in our understanding which is not computational. But how could it be if our brains work according to these laws of physics? Then I have to think, what are these laws of physics? Well, Newtonian mechanics, well, we know they're not completely right. They're pretty good for many things. There's Maxwell's equations for electromagnetism. Okay, well, these are similar things. They're deterministic equations. You can put them on the computer. You can do pretty well. Why not? Then I remembered Dirac's lectures. And there's quantum mechanics. Well, you can put Schrödinger's equation on a computer. It's pretty difficult because you have to have far exponential complication and things like that. But it's still a computational thing. So what's the problem there? But then I thought about Dirac and his piece of chalk. Quantum mechanics, see, I'm going to say something a bit outrageous about quantum mechanics. You often hear people say quantum mechanics is the most perfect theory of physics ever constructed. Well, the trouble with quantum mechanics is it's self-inconsistent. It's a self-inconsistent theory because it has these two laws, two rules. One is Schrödinger's equation, if you like. It tells you how a system evolves. You know what the state of a system is. It tells you how it evolves in time. You could put that on a computer. What's the other thing? Well, the other thing is what happens when you make a measurement. And when you make a measurement in quantum mechanics, you don't have all these superpositions. You have one thing or another. And Schrödinger himself was very well aware of this problem, and he made this famous theoretical thought experiment of the cat, which is dead and alive at the same time. And he quite correctly said, this state of a cat being dead and alive at the same time is something that, according to his own equation, you could have. And he didn't like that. He sort of confessed that he wished he'd, all this way quantum mechanics behaves, he wished he'd had nothing to do with it. So Schrödinger himself was well aware of the problem. Now, the thing is that what you do is you do something completely different. You just take this state which Schrödinger's equation predicts for you, and you turn this into probabilities of one thing or another. Now, Schrödinger's equation doesn't say that. It says these superpositions persist. Now, what do you do with all that? Well, there are all sorts of views about it, and some people say, well, when a conscious being comes and looks at the superposition, it becomes one or the other. And when you put if the Schrödinger's cat's in a box or something, and then you open the box and somebody looks in, it's the act of somebody looking in the box that makes it one or the other. Schrödinger didn't believe that. I don't believe that. The cat wouldn't believe it either, because it would know if it was dead or not. So there's clearly something, in my view, wrong with that thing. And so there's something wrong with quantum mechanics. Now, even though, and some people say it's the most, well, maybe it is in some respects the most perfect theory, but it's pretty imperfect as a perfect theory, because it has this contradiction between its two main features. And when I was thinking about what could it be in the physical world which could evade computation, this is the only thing I could think of. Now, it's not that people say, I think you brought this up, some people say, well, Penrose says, here's a problem, they must be the same because they can't understand how either one of these is the problem is consciousness and the other is the problem. Well, it's a bad argument. The argument isn't quite that bad. It's more like the Sherlock Holmes argument, I think, which is quite a bad argument too. But the Sherlock Holmes argument is, when you've eliminated all the things, plausible possibilities, then whatever remains, no matter how improbable, it must be the truth. Well, it's that argument, you see. So, no, you have to find something which is non-computational. And so it's a missing part of physics. Now, in The Emperor's New Mind and all that, I did consider these issues of computation and what they, of course, in those days, it hadn't got nearly to the point that we have today, where the incredible things that computers can do now. I was well aware that these things were going to outstrip by far the things they could do then, and could outstrip by far anything that human beings could do in calculational ways, and that's certainly true. However, what they don't have, in my view, is understanding. And I think often people say, well, do they have creativity or something? Well, maybe. How do you know whether something's creative or not? If it does something unusual you didn't expect, maybe that's creative. I think the trouble there is it's hard to know what you mean by being creative. But you know a bit more about what you mean by understanding. I think maybe some of you have this chess position on your chairs or something.
Everybody, yeah.
That was an example which I made up. It's really somewhat of a modification of a chess problem which I'd seen much earlier by David Norwood and William Hartston. And they had a set of, it was a sort of Turing test. They had a set of chess problems, half of which were easy for humans and hard for computers, and the other sets were hard for humans and easy for computers. The ones which were hard for humans and easy for computers were no particular point to them, just complicated. Easy for the computers, they just don't care about complication, but hard for the humans because they didn't see the point of what was going on there. But the other ones were the ones that would be hard for computers and easy for humans, because there was some principle, and there was a barrier of pawns, you see, which block off all the black pieces, and you could see that the pieces couldn't get through unless you did something stupid to break the barrier up. Well, this position that you see on the card is a sort of modification of that with other little twists to it, where the black pieces, although you have a tremendous material advantage, 2 rooks and a queen and 3 bishops extra, but it's a very strange position that no computer would ever have come across. So it wouldn't be in all the things it's supposed to have learned and tried all possibilities and put these in its memory banks and whatever end games and things it would have been presented with and all these things. Nothing like that would have ever been entertained by the machine. So all it does is try to look so many moves ahead, and nothing much happens, unless it does something completely stupid and it rules those out. And it's asked, who's going to win this position? And every time it says it's a win for black. Whereas a human being, look at it, you see all the black pieces are boxed in by the pawns, and as long as the white player doesn't do anything completely stupid, it's clearly a draw. And so the computers knew you can, and I think what happens after a while, it starts sacrificing the bishops because it's so terrified that it's going to draw the position, because it would repeat the pawn wouldn't have moved and a piece taken or something. But at a certain point, it's a draw if that doesn't happen. So it sacrificed the bishop. It does completely stupid things like that without realizing that the game is a draw. Now, the thing it lacks is understanding the game. That's just an example to show that no matter how well the computer plays in competition with human beings, and would beat pretty well anybody, or make a draw sometimes with a really good player, it doesn't understand chess. And that's a sort of strange paradox. But I like to concentrate on understanding. You see, I also never quite liked the word intelligence. I never quite liked the term artificial intelligence, because it's saying intelligence is what these devices have. And I rather think that in normal usage of the word intelligence, that an entity is not really intelligent unless it has the quality of understanding. Now, I don't know what any of these three things mean in the sense of giving you a definition. Intelligence, understanding, consciousness. So I'm not trying to define any of them, but I would say that to be intelligent, I would claim, the normal usage of that word, it has to have the quality of understanding. And I'd also say, in order to have understanding, it would have to have the quality of consciousness. Because in normal usage, you would say that a thing is, you wouldn't say a thing was intelligent if it didn't understand. And you wouldn't say a thing would understood something if it wasn't aware of things. So in the normal usage, it seems to me that intelligent thing would have to be conscious. And it would have to have understanding. And the arguments that I presented in connection, they were all mathematical arguments, and sometimes people say, oh, well, mathematics, that's a very limited area of what consciousness is used for. I mean, what about the appreciation of beauty? What about the feeling of pain? What about appreciation of the color red, which is a conscious experience? And all these things. Yes, of course, yes. Those are all things to do with consciousness, certainly. But I have nothing to say about them because I can't make a mathematical statement about them. The reason I'm talking about mathematics is because you can make a mathematical statement about these things. You can see that the mathematical quality of understanding something in mathematics is not a computational thing. And this example, the Gödel example, was what I concentrated on. The chess positions are limited in a way because they're all finite, and you could have a program which, they're getting close to it. They don't run through all possibilities as yet, but it's sort of, in a sense, getting close to that sort of thing. The amount of computational power that these machines have is utterly incredible. But the arguments from the Gödel theorem come from infinity. And no matter how much power these machines have, they're not going to be able to deal with infinity. And the Gödel thing it does deal with infinity. Now, you might say, how can we think about infinity? People often say, well, infinity, you can't really think about infinity, can you? But you can, and I can give you a very simple example. I'm going to talk about numbers here. If you have an even number and another even number, and you add the two, can you get an odd number? Now, that's a statement about an infinite number of things. And you just think for a moment, and sure, you can't do that. You add two even numbers together, you're always going to even number. That's a statement about an infinite number of things. So you can make statements about infinite numbers of things. Now, you can formalize that, and you can talk about what kind of mathematical systems can see which things are true and which things aren't true, and Gödel shows the limitations. And the limitations are not the limitations of human understanding, because you follow through those arguments. They can be hard to do, and I'm not saying it's trivial, it's not. You can make it a lot easier than Gödel's argument, which are really complicated. Using Turing's ideas, you can make it much, much simpler. But even so, it looks a little bit of a... You have to twist your mind around and see that it works. But it's not that hard to see these things are... The Gödel statement is true, even though you can't derive it using the rules that you've allowed yourself. How do you know it's true? By understanding the meanings of these rules that you've put there. And if you didn't understand the meanings of those rules, you could prove something else. You'd think something else, negative of the Gödel's theorem, was true instead. And how would you know which is which? And if you didn't appreciate what these rules came from, what they meant, your understanding of what they meant, you wouldn't be able to deduce the Gödel thing. Now, what does it mean to understand what they mean? I don't know. It's a mysterious thing. But that quality is what we use our consciousness, one of the many things we know our consciousness for. Now, you see, there's a real problem here which comes up. How did that come about in natural selection? And I often use this argument. And there's nice examples I often use. It's a thing called Goodstein's theorem, which is a simple thing you can explain. I won't do it here, but it's a simple thing you can explain to people. They don't have to have much mathematical understanding at all. It's a simple thing with numbers. And you have a process, a little step-by-step process, and you start with any number, and that number grows bigger and bigger and bigger and gets huge. Absolutely enormous, far bigger than could conceivably dealt with by any computer envisaged at the moment will ever be. These numbers go absolutely huge. And then they start coming down and down and down, and they end up with 0. Now, how do you know that they end up with 0? Well, you see, the normal rules of how you prove things in mathematics, what's called mathematical induction, how you can prove something, something that's true of an infinite number of things by just a finite number of statements. You know, if it's true for n, then it's true for n plus 1, and if it's true for 0, then you know it's true for all n. So that's what's called mathematical induction, sort of thing you learn at school. You can never prove this thing using that. How can people have evolved who could see that it's true? It's not so hard to see that it's true. Well, it's a little bit difficult, but not that hard to see that it's true. How can you beings have evolved to be able to see that if they only had experiences of killing mammoths, building mammoth traps, and building houses, domesticating animals, all the sort of thing that helped the evolution of the human mind, the human brain. But sophisticated mathematics wasn't in any of it. But what did evolve was understanding. And that understanding quality was something which surpassed any of these individual uses of understanding. It was useful for all these different things. But in particular, it was useful for mathematics. It was sitting there, evolved for being useful in mathematics. Not specifically to do with the mathematics, it's just that it's that same quality of understanding which is what we use our consciousness for, one of the things we use our consciousness for. So I certainly think that consciousness is a physical quality which evolved through natural selection. Absolutely, I believe all that. It's something which seems to be outside the computational world. Now, it has relevance very much to where artificial intelligence is going. And sure, we build these devices which can drive cars. I mean, I don't know quite where they've got to yet, whether they can drive cars down maybe motorways, or I should say expressways. What's the right American term? Freeways. Sure, you can make them maybe. What about crowded streets in Italy or something like that? I mean, I'd be more doubtful about how good they would be there. But okay, maybe in a little while you'll be able to do that kind of thing. I'm quite prepared to accept all that. But they won't have consciousness. They won't understand anything. Like the chess machines, they won't understand a thing. But they will have used human understanding to develop these devices. I mean, they're not building the artificial cars. It's the human beings who know how to make these devices, these computational devices, that use the fact that they can do tremendous, complicated calculations, but the understanding comes from the human beings. And the understanding is a quality of consciousness. Now, going back to where does it come from, you see? Well, the argument, when I wrote The Emperor's New Mind, I rashly started writing the book before I knew how I was going to finish it. Now, of course, that would be a very bad thing to do. I believe people who write detective stories, I don't know if they ever do have that. I think you probably should have a good idea where the thing's landing. But I did learn about a little bit about how neurons worked and what the view was, Hodgkin-Huxley and and how these things worked. And I convinced myself pretty well. You see, I wanted to see where is a role, not just for quantum mechanics. You see, it's worse than that. When I say worse, I mean more unbelievable. Because people often say, how can there be quantum effects in a warm and wet environment of a brain? And, okay, it's hard to see. But then you have to say quantum effects. Well, it uses chemistry. And chemistry is absolutely quantum effects. I mean, chemistry is, couldn't have chemistry without quantum effects. It's full of it. Okay, so you get used to chemistry and say, okay, well, we don't count that. Anything else apart from chemistry, quantum effects? That's amazing. How could quantum effects be relevant in the brain? Oh, well, you want quantum coherence, you want quantum entanglement, things a little more sophisticated going on in the brain. Something more subtle about quantum mechanics. Well, we learn in photosynthesis there are these subtle things going on. In the mitochondria, they seem to be using quantum tunneling. In bird migration, there seems to be also sophisticated quantum things going on in the warm, wet environments of the brain. I didn't have an answer to that in my book. I came to the end, and it sort of petered out at the end of the book. But I was fortunate enough to have, I hope that it would inspire young people. I got lots of letters from old retired people instead, because they were the only people who hadn't enough time to read my book. But fortunately, Stuart Hameroff found the time to read my book, and he wrote to me and said, look, it looks as though, he didn't put it quite like that, but he said, it looks as though from your book that you don't know about microtubules, which was absolutely true. I had not heard of microtubules. And I get a lot of nutty letters from people, I should say. Oh dear, what's another one like this? And then, of course, I look it up and say, my God, they're really there. And if I thought these structures, now here's something with a chance. Something, not just that you have a possibility of isolation which could preserve the quantum coherence to the level we need, but you also have structures which are sort of crystalline in their repetitiveness, and that's very good for quantum mechanics. So it did seem to me you're in with a chance there. Now, I haven't quite explained my problem here, you see. It's not just people are suspicious of subtle quantum effects going on. I'm saying something much worse than that. Much worse than that, in the sense that we are looking for where quantum mechanics goes wrong. It's not we're looking for quantum effects. We're looking for where the quantum mechanics we understand has to be replaced by a better theory. And that better theory explains how these choices that seem to be made in quantum systems, when a so-called measurement is made, the chalk is here, or the cat is dead or alive. That's not part of Schrödinger's evolution. That's something else that happens. And there's no part of quantum mechanics which explains when and where that happens. So one has to look carefully into other areas of physics. And I have my reasons for thinking that where we've got to look is in the general principles underlying Einstein's general theory of relativity. And there are good reasons for this, which have to do with subtleties of how quantum field theory works and how it's at odds with the way Einstein's gravitational theory works. Sometimes people say, oh, well, gravitational interactions are ridiculously tiny compared with all the physics, all the chemistry, and all these other things. Yes, that's absolutely true. But that's not what we're saying here. We're saying that the principles which Einstein's theory are based on are in competition, they're in contradiction with the principles of quantum mechanics. And this is where you have to look for something else in which the choices nature makes between one thing happening or the other thing happening, that's something non-computational. That's the argument. But the brain must be making use of that. Now, this is an outrageous statement because it's not just that quantum mechanics in a coherent way is happening in the brain, but you're getting to a level where you have to bring in something which we don't even know in current physics. Well, I happen to think that's true, and that consciousness is not just something which happens to come along because something gets very complicated. I mean, I find that very hard to believe for very simple reasons. Here we've got this part of the brain, the cerebrum. It's got quite a lot of neurons there, 10 to the 11, something or other. We've got another part, the cerebellum, at the back here, which has got pretty well as many. Not quite, but pretty well as many as there are there. Far more connections between these neurons than there are here. It seems to be totally unconscious. What's going on in here, this part, the cerebellum, which is completely different from what's going on here. And you seem to have more computational potential there. It probably is. The cerebellum, if you see these, well, I'm living yesterday in the tennis club. And La Jolla. And when people play tennis, I mean, most of what controls these muscles and what they're doing, they're not thinking about what all these muscles are doing. It's the cerebellum which is doing all that, and it does it much more effectively and quickly than the cerebrum does. The cerebrum is using for overall strategy and what thing they're going to do next and so on. It's not being used for the control of exactly how they hit the ball and this thing. That's all taken over by the cerebellum. Computational, sure, I believe that. But it's not conscious. It's not doing what the conscious brain, it's not having the understanding. It doesn't need it at that point. The understanding was there, and it'd been put into the cerebellum. It's been programmed in some very clever way into the cerebellum to do these unconscious actions that are going on. So, to me, consciousness is an absolutely crucial thing to what people are doing in intelligence, not, let's say, AI, because AI as we know it is computational. That's by its very nature. But it's not, you see, I think there are dangers, not that it's going to take over from us, but it may be upsetting all sorts of balances that we don't fully understand, connected with how people make use of these things. I have no idea. But this is a new technology which is going to influence things in a tremendous way. I completely agree with that. But it's not going to take over the jobs which we use our understanding for, because it doesn't have that quality. So that's my view. I think I'll stop at this point.
Great. Wow. Wow. So that's actually reassuring, especially your final comments. Woof. So Eugene, so do you feel intelligence requires consciousness? Does consciousness require something that's beyond computation? Are your robots really just artificial cerebellums?
Have you noticed that we're almost 1 hour of discussion and both of us avoided defining what consciousness means? Actually, my favorite definition is the definition that I heard from Edelman. Consciousness is something that appears when you wake up and disappears when you go to the office. On a serious note, let me summarize your major thesis. Is that you're saying that if brain is a computer and computer acting according to a certain finite set of principles, then you can formulate a task that people can solve easily, but this computer cannot solve, just using Gödel theorem. And you try to give examples of some tasks of this. Therefore, the reason people are doing this is because they have understanding which doesn't come from following set of rules. Therefore, understanding that people have doesn't come from computation, must be something else. And if all the other explanations are excluded, therefore, they must be related to quantum physics, because there you have very similar phenomena of entanglement and decoherence and coherence and just something very, very similar in spirit. So there are 3 major problems that I see with this. One of them could be fixed, 2 others cannot be fixed. The first problem is that the examples that this chess example, for example, yeah, it relies on the algorithm that will be killed by combinatorial explosion of number of steps. However, and this will be a very valid argument 5 years ago, but right now we and Brain Corporation, DeepMind and Google develop algorithms that act according to different principles, where you don't go through all the possible steps, but you use reinforcement learning, you use deep learning, and just you can look at you acquire a certain understanding of positions without going deep, without enumerating all possible steps, deciding which step to go first. So this could be fixed because you can always come up with the other types of problems that people have. Some people have no difficulty solving, but computers at that stage still have problem solving. But computers always catch up. So this is one. This is not the biggest problem. The biggest problem is that, from my view, that all your arguments are absolutely true if human brain, conscious brain, was in a vacuum, disconnected from the body, and the body was not in the environment. The reason people solved all those puzzles that computers may not solve using a kind of straightforward approach is that we Our brain is embodied, our body is embedded, and we have our lifetime of experiences with a very complicated environment, with other people. That the environment doesn't always follow laws of logic. Things are sometimes illogical. So when we look at the problem, we use not only just a set of rules, we use all our lifetime experience, which we obtain from learning how to live, how to navigate, how to deal with other people and the environment. And this is the fundamental difference, is that the system is not closed, like with the argument for, if you want to use quantum physics for those arguments. The system is open. And my lifetime experience comes from Russia, living in Arizona, living in California, dealing with the smartest people on this planet, and most of them are in this room. This is something that gives me extra information that I don't have to follow a set of prescribed rules, because I'm allowed to make mistakes. And this is the fundamental difference for me, is that if we want to build intelligent, smart machines, and I'm going to answer your question in a second, whether intelligence implies consciousness, is that we cannot build them in a simulation alone. We have to take our simulation, this brain, and put it in the real body, and put this body into the real world. And then, even though the simulation itself follows rules, but it absorbs all the complexity through learning, absorbs all the complexity from the real world. So when this simulation, when this robot deals with new circumstances, it exhibits behavior which everybody, including you, will be compelled to call understanding. Even what we did at Qualcomm, when we were at Qualcomm campus, we can teach, we can train a robot to avoid obstacles. The robot has no idea what obstacle is, and pretty soon, if it sees something which it never saw before, it knows how to avoid it. We had simulations where we have robots which were trained through reinforcement learning and supervised learning, which would exhibit behavior that you'll be compelled to say that the robot is afraid. Robot can navigate in a well-lit space, but if there's a shadow somewhere, robot will avoid it. It will be even if you push it, it doesn't want to go there. It's almost like animal-like behavior. We can go on and go on with such behaviors where a system, when it's embedded in the real environment and is allowed to learn from the real environment, absorbs the complexity of this environment, so that when it solves problems, even though inside there's a very strict computation run on Linux, written in programming language, and there's no randomness inside, the randomness from the external world gives it, and all the experience gives it ability to find new creative solutions for very tough problems which they never encountered before. So, and this is the fundamental difference in my view, that why you cannot apply Gödel principles to an open system, to a very complex system. And finally, your comment is that if smart implies intelligent, and then intelligence implies consciousness, then Siri is correct, my smartphone is conscious. Oh, wow. But I don't think this way. I believe that that you could have intelligent behavior without being conscious, and again, it boils down to definition of consciousness. Irvin mentioned an article where dolphins' porpoises can pass the mirror test before human babies can. Does it mean that human babies are not conscious? If you ask a baby, 6-month-old baby, are you conscious? Or you hear in the response will be, meh, meh. Does it mean that it's not conscious? And even this test, mirror test, there's a problem with the mirror test. It's so human-centric because humans and primates are such a visual animals. So the test was designed to discriminate against animals which have much keener perception, but not in a visual space. In fact, my favorite example is by Rodolfo Linus, who said that if dogs were to administer mirror test, they wouldn't use mirror, they would use a fire hydrant, and they'll ask human, can you recognize your own urine at the fire hydrant? And if you cannot, you failed the dog's mirror test. So to define, so what I'm curious is that, and maybe this is the chance, that to hear your definition of consciousness, intelligence and consciousness, how you can define it.
Well, let me say, first of all, that I I said already that I don't define these words because I don't know how to. But on the other hand, consciousness is something we experience, so we directly know what it means to be conscious. And I would say you raised an interesting question when you said when you go to sleep. That question that I would say, when you're put to sleep, you see, recently I had a hip replacement, and so I know about these things. But one of the key ways in which you can explore consciousness, often you can have these arguments, about, is this thing conscious or not? But one of the key ways is when you put them to sleep in a reversible way, and this is where Stuart Hameroff comes in with his take on all this. Because being an anesthesiologist, it's his job to put people to sleep in a reversible way. And this means turning off consciousness, very specifically. And they're not aware of what was going on when they were under the general anesthetic. Now, what is the general anesthetic actually doing? And that's one of the really it's clearly directed piece of research which is directed towards the very issue of consciousness. Now, I don't know many things which are. That's one of the few things which we know addresses the question of consciousness. Now, whatever it does, whatever general anesthetics do, they turn off consciousness very specifically. So if we understand well what is going on there, well, then we have a good route to what is actually responsible for consciousness in human beings, or in not just human beings, but other animals and so on. So that seems to me a very important point. Many of these other things, you say, well, we don't know whether this machine's conscious or not. If it screams when you hit it, you could not program it to scream when you hit it or something. I mean, is it really feeling anything? And there's all these questions. I mean, if you touch a hot stove and you pull your finger away, you've pulled it away from the stove before you actually feel it. Because that's something that's programmed into it doesn't get as far as being conscious. So, is it a good test to know whether is it feeling pain just because it pulls it away? No, because that isn't, because it doesn't feel the pain until after it's pulled it away. So, I mean, it's often very hard to know about these timing questions because there's a lot of subtleties about that too. But, I don't know, I mean, there's lots of questions here about how you know operationally whether something is actually feeling anything. I mean, how do you know whether your computer's got consciousness or not? If you believe it has, I mean, this is the thing people often say. You like to have these machines which are really good artificially intelligent machines because then you could send them off to a distant planet, explore it, send the messages back, and leave the blasted thing there. Now, if it's really conscious, you've got no right to do that because it is then a conscious being. You've got to bring the thing back. I mean, sure. I mean, I don't believe it is if it's just a computer-controlled device. But, I mean, these questions have to be raised, sure. But we don't know from its behavioral aspects. I mean, it's very hard to tell whether it's conscious or not. Although when I say it's hard, it's not that hard because there are these Turing tests which are every year. You have to try and tell which, I mean, you'll have a lot of questions. They're very restricted in the areas you're allowed to use, but never mind. And you have a lot of questions, and then you put these to humans or computers, and you're not supposed to know which are which. And then from the answers, you're supposed to be able to see if you can judge which are the humans and which are the computers. So that is an operational way of making a distinction. But so far, it seems to be pretty clear which are which. But despite the fact that, what's the name of this lady computer who got...
Sophia, who's just been made a citizen of Saudi Arabia.
Yes.
Yes.
Oh, yeah.
Yes, so I mean...
That was in the news yesterday.
Yes, that one was just recently in the news. But I mean, I don't think there's much doubt about it. If you're allowed to ask this thing, questions of any sophistication, it becomes utterly clear that it's not conscious.
Yeah, and Sophia is generally, it's fairly scripted, but she gives a wonderful illusion of being a human being. And if you see someone who knows Sophia up on stage and they talk to each other, if you feel like there's a human,
The human being has been pre-programmed of what questions...
Both have been pre-programmed,
Yes.
Now, there's a big project there to turn Sophia from something that's pre-programmed to artificial general intelligence, and they've just raised a bunch of money to do that. But that's a big project to do.
Yes. Well, there's an interesting question there, you see, because when I say it's hard to tell whether something's conscious or not, in certain respects, if it's like a human being, it's not that hard to tell. Because things like this, you don't need much in the way of general conversation with this device to know it's not conscious.
You don't, no.
And these Turing tests, which are very restricted in the areas which you're allowed to put your questions in, you still pretty well clearly know which ones are conscious and which aren't. So what is it that's in a way easy to tell? It's easy to tell there, but it's not so easy to tell whether an octopus is conscious. I think there is good indication that they are, but not from that. I think, there was an experiment done with octopus. I remember this one. They had the octopus in a tank, and it was these sort of men all with white coats. I suppose they mostly were probably men and women in white coats. And the octopus was allowed to pull a chain, and that opened the door. And then the octopus got its food. And the octopus, after a while, got completely fed up with this and started yanking the chain and throwing it away or something. And then it went up to the top and started squirting all these people with white coats. And so it seemed to me that was a much better indication that the octopus was conscious than whether it could open the door by pulling the chain.
I would like to point out that when you said that when you wake up, you know what consciousness is. Actually, I don't. I know what consciousness feels because I feel it.
Sure.
But I don't know what it is. And this is actually one of the fundamental questions, is that without definition of consciousness, we're lost, because then we have a tendency to
Morphize.
Yes,
Okay.
thank you. Behavior of other animals and even robots, because we don't know what octopus feels. Does it feel the same thing as I feel when I'm conscious? So you look at the behavior and you ascribe, like I said, to robots. Robot is afraid, robot feels pain, robot is learning by reinforcement learning. So, and this points to the fundamental issue that in the field of consciousness right now, we're at the same stage as information theory before Claude Shannon. We desperately need to define this, because once you define it, you can measure it, you can simulate it, you can prove things about it or disprove things about it. So, and applaud anybody, including you, who tries to address this issue. Other people will be Giulio Tononi. I disagree with his definition, but I applaud his attempt to quantify it and bring information theory in notions of integration information and entropy to define what you need for consciousness. But I want to go back to the fundamental problem that I have with your argument is about the computers and why you need something else besides computation. Is that if you program a computer to do tasks, you have no matter how big your program is, it's a finite list of 1 million instructions, 1 billion instructions. Therefore, the computer will act within these instructions. However, what we learned with artificial neural network research, with AI research during the last 20, 25 years is that this is a wrong approach. A better approach, you program a computer to absorb information from the outside world, from the sensors. You write the program that doesn't define steps, but the program that lets computer to learn when it's in the real environment. It lets a robot to learn from real environment, real sensory data. Basically, the program only lets this, the program, like a sponge, absorbs information from the outside world. And you can have two identical programs, but put them in different locations, they will have different behavior. Like two identical twins will have different behavior. They're not identical in they're not exact copies of each other. So, and this is the fundamental difference, is that, yes, you have rules that you can write, and maybe even short rules, but because you put your robot in the real environment, and robot learns from the real environment and absorbs all the complexity of the real environment, this is where ingenuity comes, and problem-solving skills, and even understanding. Now, I say understanding and intelligence, but again, without defining it, without having a formula or definition. I'm trying to extrapolate what I feel when I'm conscious to what this robot feels or this animal feels, or what you feel when you are conscious. And this is where I think is extremely important for us to move this field forward, is to try to apply mathematics and quantitative science trying to define all those notions, pretty much to bring consciousness research to the same stage as information theory was brought, 80, 90 years ago.
Okay, thanks, Eugene. So what I'd like to do, to keep in the interest of time, is switch now to take some questions from the audience. And so we'll have a time for a few of those, and hopefully Oleg and James, you guys can join in too and add your thoughts. So Raj Tuluri.
Okay, so this fascinating discussion on consciousness, intelligence, understanding. So the question I have is, just in terms of background, I worked on computer vision. In those days, people talked about computer vision, computational vision, image understanding, and so on. But the question I have is, if we apply von Neumann architectures and the concept of Turing machines and linear programming and the way the machines work, then there is this question of can you program consciousness? But nowadays, it seems to be more about machine learning and training data. So is consciousness an experience that is learned by architectures that we haven't quite comprehended or not? So because right now, we train machines with a lot of data, and suddenly they seem to do things. And I don't think anybody knows how they do things. So are we mimicking a different computational paradigm that's getting machines consciousness or intelligence or understanding by training? Because if you took a human being and put him on an island where he has no experience, will he be conscious? I guess that's the question. Is it training or is it programming?
Is that a question to me? Well, I don't see I don't see why it shouldn't be conscious just because it may not have a developed consciousness, which somebody in an environment which is better. I don't see why it shouldn't be conscious. Why do you say not? I don't understand. I mean, I think a mouse is conscious. I mean, it hasn't been to school.
My question is consciousness a learned experience? What is an inherent characteristic of a human?
Well, no, I don't. If you're asking my view, I would say no. I mean, because I don't think consciousness is necessarily a human thing. And I think there's so much evidence that animals, in all sorts of respects, it's not as developed as it is in us. I think that's certainly true. I don't think consciousness is an on or off thing. I think you can have more consciousness. I mean, in certain states of mind, if I've had too much to drink, I'm probably not as conscious as I am when I'm all alert and stuff like that. Or when I'm half asleep. When I am asleep. When I'm dreaming. Okay, when I'm dreaming, I am to some degree conscious. I'm aware of things going on. They're not things out in the world. There are things in my head. But I certainly have a low level of consciousness. So consciousness, in my mind, is certainly not just an on or off thing. So some individual brought up in circumstances which are not good for developing sophisticated aspects of consciousness is still conscious. I think the dog is conscious. I think the porpoise, whatever the thing was, dolphins, I can't remember what it was, but they're conscious. But probably not to the level of human beings. Although I should think with many animals, it's not that far off. Elephants, I think there's a really good evidence that they have a very significant. I mean, there are these things about elephants. I remember one of these David Attenborough programs in which the herds, it's always the female who is in charge of the herds. The males are running off doing other things. But the female, and then they had to get from one place to another. And they decided, the leader of the herd decided, look, we're not going straight there. We're going to deviate, go to somewhere else, because that's where her sister had died. And all the other elephants go there, and they pick up the bones, hand them one to the other, and sort of stroke the bones all the way around. Now, what are they doing that for? Well, it's a bit like having a religious sort of experience, and people respect for their relatives and so on. I mean, you can see, am I anthropomorphizing? Or is this a quality that can be really understood as these elephants having deep feelings, which is what I do believe. They're enough like us that they have deep feelings and clearly conscious. They may not have the level of consciousness that humans have. I don't know whether it's far off that, though. They don't have these things that we have, which is terribly convenient if we want to construct things, and they have their trunks, which they can do an awful lot with, but not quite as convenient as these things that we have, which can construct things for good or for bad.
So I probably didn't say it right. I don't think
Let me
humans versus animals. I just meant more like living things versus computers. Is it a learned thing versus an inherent thing?
Well, I think there's something other than learned thing. I mean, if you can put your computer in the field and dance around and talk to it and try to make it feel something, and I don't think it would. So that quality is necessary. You might stunt their ability to be conscious in some ways. I think that's probably true, by giving it an upbringing which is very deprived in many ways. You might keep it locked up in a cellar and just shovel food in. You know, there are awful cases, you hear about these things. And I'm sure that does affect the consciousness, and it probably stunts it. But I don't think that anything you do to a computer would make it conscious just by stuffing information into it. I mean, okay, you can argue other ways, but I think the evidence is that whatever consciousness is a quality which requires something. I mean, I think it's got to do with the microtubules that Stuart taught me about, and I think it has to do with having quantum effects which are raised to a certain level. But then you ask questions, why did it get to that level? Surely quantum effects must be useful in biology before that level, otherwise they'd never have evolved to that level. Yes, I think that must be true. And we see evidence, photosynthesis. We see there are these sophisticated quantum effects which people thought would never hold in these warm bodies. And we see that photosynthesis is critically a quantum phenomenon. Okay, there must be lots of other things in biology which haven't got up to the level at which this new physics needs to come in. And that's where I say, unfortunately, you see, people ask me, how could I make a device which has this quality, which isn't a biological system? And I would say, I have no idea, because we don't know enough. We don't know enough about the physics yet. We certainly don't know how to do it. But could we, in principle? Yes, I think so. I'm not saying that it has to be, to answer some of the questions you raised before, I certainly don't say it has to be biological. Biology is how it's been done so far. And that at some level, we will get the understanding. It needs, the physics has to be developed. It's not just understanding what biological systems do. We have to understand what quality it is that we get out of those laws of physics that we don't yet properly understand. But then it means that we've got to study the physics too. If we're really going to understand consciousness, we have to develop our physical theories too. So this is one of the reasons that I think in the institute which you referred to, we don't just study what we think is going on with regard to consciousness, but there are very important questions in physics which have to be resolved, not just for this, but all sorts of other things, which are spin-offs maybe, which are qualities which will find importance in technologies of the future. And so that's fine. But I happen to think that consciousness is not something we're going to have an answer to until we've resolved the physics further. That's, of course, a different response than we get from Eugene, but we want to see different viewpoints, and that's part of the idea. Yes, well, I'm saying that my view is that it's not just training, certainly not. No. Yeah.
Thanks, Raj.
Yes, another question for Mr. Penrose. You mentioned the continuum of consciousness.
Yes.
Is there a point along this continuum of organisms that you can think of, for example, a bee that we could simulate computationally? And at what point are we going to reach a limit that you believe?
Yes, it's a very good question. And I remember once, I think I must have been about 12 or so. So you can see I was thinking about these things earlier on. When I saw a film which was about insects and things like this, and whether these insects, and I was wondering about this question, do these insects feel anything? Are they aware? Are they conscious? And in this film, you saw one insect, a big insect, eating a little insect. You know, apparently enjoying its meal and eating this little insect. And then the film panned back, and you saw this big insect was all the time being eaten by an even bigger insect. And it didn't seem to care at all, the fact that it was being eaten. And I thought, that can't be conscious. But of course, maybe it was enjoying its last meal, I don't know.
But is there a point in that continuum of consciousness that you think, or do you not think that any, even the tiniest
I think there is a point, you see.
Okay.
Yeah, it's probably to do with, I mean, I think Stuart may have a slightly different view from me on this. I'm not sure. It's a question of how consciousness it is, or is there a level at which it really isn't conscious? Does the consciousness require... See, in this view, you really require a certain level of mass displacement. You see, it's Dirac's piece of chalk, you see. You have to have the thing in two states at once at the same time. And how much mass do you need? Well, it isn't really a question of how much mass, but how much mass... The more mass there is, the quicker it happens. If there's less mass displacement, then it can be very slow. So I think Stuart would argue maybe the insects have a conscious, but it's sort of very slow. I'm not sure I think of insects quite that way. So I'm not sure. It may be that they're not conscious, but I'm not sure. Bees are incredibly clever.
My question is whether or not you believe that we can simulate those low levels of consciousness computationally.
It's a good question. I mean, yeah, could you simulate a bee? Well, they seem to solve these problems. Well, I don't know. It's just a traveling salesman. It's a bit of the traveling salesman problem. Apparently, there was some recent research, wasn't it, about some bees they found it took a bit of a complicated route to get there, and then they learned how to go straight there rather than doing the complicated route.
I think the straight answer to your question is that we don't think you could simulate consciousness with a classical digital computer, right? That consciousness is this thing that gives you mathematical creativity and so on, and that a classical computer can't do that, and a human brain can.
Even if it's hooked up to a sensor that detects randomness from the outside world? I mean, I understand novelty is an aspect of consciousness.
Yes, so you can imagine a machine that had free will, where it decides, it gets to the end of its choice, and then it picks a true random number from a cosmic ray, and it goes yes or no, right? And it has free will in some way, but all it has is freedom. It doesn't have any will. It made no choice. It didn't think about it. It wasn't conscious. It just got to the end and then just did something. So I think that what you're looking for in a conscious being is this ability to make decisions that I will go and do something. I'll wake up this morning and I'll build a new kind of device or a new invention, and that's a fully made choice that we make, as opposed to just a random number that we flip.
I think we're in dangerous territory with free will discussions, right?
I promise.
We're not
to
at the
say
neuroscience
free will.
department. It's okay.
Yeah.
Is Stuart here?
Yes, thank you. I'm Stuart Hameroff. It's been my great privilege to collaborate with Roger on our theory of consciousness. This is for Eugene. Given that anesthesia, let's follow on the anesthesia story, that anesthetic gases act strictly by quantum forces, van der Waals-London dipole dispersion forces, and the brain is quite active under anesthesia. The membranes are active, neurons are firing, we have evoked potentials, we actually do that under anesthesia. So the only thing that's really missing is consciousness. And so it's selective. And recently we showed in a paper in Nature Scientific Reports that anesthesia acts by dampening quantum vibrations in microtubules. So given that, and given the fact that microtubules have been shown to have quantum resonances and other biological entities have, why do you think quantum physics is not necessary for consciousness, specifically Roger's view, and why do you only, when you model your neurons, look only at the membranes and ignore what's going on inside the neuron?
So actually the answer to your question is in that paper that you just cited, that actually shows that it's a correlation between anesthesia and action on the microtubules. It's not a causal effect. You couldn't prove the causality that because you messed up with the microtubules, therefore you have loss of consciousness, even though all the other vital signs are okay. Because we know that anesthesia, first of all, it depends which kind of anesthesia you use, what kind of gases, but they have very broad effect on the brain. They affect the other parameters of the brain, sodium channels, voltage-gated channels, other...
No, that's not true. Well, they have effects on all those, but they're all different. There's many gases, and the only common entity that all the gases act on, and gases which are not anesthetics do not act on, are the microtubule quantum vibrations.
So again, this is like in your paper, just you acknowledge that this is a correlation. You showed correlation between conscious state and the fact that you have different vibrations in microtubules. But is it really causal? Do you really need it? Because I can also show other correlations. The human is motionless. Doesn't mean that consciousness depends upon motion, because it doesn't move. The brain activity, the gamma activity, the alpha activity, other types of rhythms change their behavior. Doesn't mean those rhythms cause consciousness. No, they correlate with that. Maybe it still could be something else that is affecting it, which results, think of this as a computer with parameters. When you put anesthesia, you change the parameters, and you change some of the parameters, the consciousness disappears. So you cannot claim that it's microtubules that cause loss of consciousness. You can only show that the change in their behavior correlates with the state of consciousness. And this is very important, and I don't think you're going to argue with this statement.
It's a correlation, but it's the most specific, detailed correlation ever put forth. And yes, breathing correlates with consciousness. If we don't breathe, we're going to lose consciousness. Many things correlate with consciousness. And we can't directly measure it, which is a problem in anesthesia, because we can't absolutely ensure that our patients aren't conscious. So we compensate for that. But the effect, anesthetics act only by quantum effects. They act on microtubule quantum vibrations. And I think by ignoring what's happening inside the neuron and only looking at membranes where you have strictly algorithmic Hodgkin-Huxley activities, when in fact neurons in awake animals deviate from Hodgkin-Huxley spike by spike by spike. There's some internal process modulating the spiking, and that's where consciousness is most likely to be in the dendrites and soma, triggering the spikes. And we think that's in the microtubules.
Right, so this is a separate question. There's one question about microtubules and experimental results. And by the way, I applaud anybody who spent effort trying to find neural correlates of consciousness. And this is a neural correlate of consciousness, something that you can associate as closely as possible. Totally separate question is that what is the level of abstraction that you need to take when you try to simulate the brain? And do you need to take into account all the deep effects? Where you stop? Even if you simulate microtubule, somebody, a string theory person says, no, you have to simulate strings and go even deeper down. And this is a matter of what kind of phenomena you have to achieve or want to simulate. I'll give you one example. I developed a model of a brain, of a neuron, that I call it simple model. People use my name, call it Izhikevich neuron, which is very simple, has very few parameters. It takes into account what happens inside the slow dynamics inside the cell body by changing those parameters. And what I can demonstrate that I can record from a red slice, from visual cortex or motor cortex, I can find two neurons which are close to each other, two sister neurons which look nearly identical. When you record from them, they have slight deviations in their responses to pulses and other inputs. I can tune a model such that the difference between my model and this neuron is smaller than the difference between this neuron and sister neuron, which means that we have the tools right now to simulate neuronal dynamics to such a point of precision, responses of neurons to stimulus. Not everything, it's a biological cell, it's a factory, it's a chemical factory. But to simulate functional response of neurons with such a precision that we can simulate individual neurons, and then we have a sister neuron, which is supposed to be the same but slightly different, and the model will simulate even those differences. So the question that you're asking is that, why don't we go deeper into this? And this boils down to what you want to simulate. If you want to simulate learning responses, you don't have to go deeper. You have to take into account synaptic plasticity and other subcellular effects, but you can write simple equations for that. But if you want to simulate intelligence, you have to put it into a robot and see the behavior. If you want to simulate consciousness, and this is the guts of our discussion and debate, is that what is consciousness? I know I can feel it, but if you give me a definition, then maybe I can answer the question, say, you're absolutely correct, we have to go deeper because according to this definition, we cannot stop on the neuron, we have to go subcellular. Or the opposite, maybe the definition such that you will tell me, Eugene, don't waste your resources simulating individual neurons, you have to simulate groups of neurons, dynamics, because the definition of consciousness requires some other level of activity. And this is why information theory was so lucky to have a definition. This is why consciousness field is such a disarray right now, because we all know how it feels, but we don't know what it is.
I don't think it's in disarray. But if you want to go, if you want consciousness, you have to, you didn't answer the question why you don't need the quantum effects at a deeper level, which is at least the best correlation we have. And if you want consciousness in vitro in a machine or a device, you may not need neurons. You may just need microtubules.
But this is like simulating communication channel. Say you have a copper wire and you're talking about Morse code 100 years ago, and arguing that you have to simulate the channel, the copper, the length, because look, the wavelength and all this depends upon how those pulses are transmitted. And maybe before Claude Shannon, this was a very valid argument. And I'm sure a lot of people were trying to do that. Maybe the biggest achievement of Shannon was that to abstract from the physical substrate and look at it from a mathematical point of view. And yeah.
Okay,
That's actually worse. It's my opinion.
We're definitely not going to sell this. So I'd like to, one more question, and then I'll ask everyone to give a final comment, and want to make sure that Oleg gets to participate a little bit too.
Sorry,
one last question.
So it seems like this, what is the fundamental nature of consciousness, is kind of like an important question. And usually in science, when there's an important question, people pose an experiment that determines whether it's true or false. So it's a bit disturbing, kind of, that no one has even begun to agree on an experiment that would determine whether consciousness requires quantum effects or not. And it seems like it's hard to say whether the brain is using quantum effects, as we saw there. So for instance, this chess example, I would imagine that a modern chess engine would be able to solve this, but even if not, we could program it to solve this particular example, and we could program it to somewhat generalize and solve similar examples. So it seems that there's some kind of no true Scotsman thing. Every time an example is posed that this cannot be done by a computer, and a computer does it, then this is put in the category of things that don't require consciousness. So is there anything that both sides can agree on that would actually answer this question, that would say, this is an experiment that if this result comes out, then consciousness is not doable by modern computers. Otherwise, it is a quantum phenomenon. So is there something that people can at least begin to agree on that would determine which side is right here?
It's a very good last question.
Well, obviously. Sorry,
Maybe we'll start with Oleg and then with Roger, so that Roger has the last word.
Okay, so...
I think unfortunately we cannot agree with any experiment because, in my opinion, the consciousness has a mixture of a lot of things. So one of them is intelligence, and the second one is this feeling that you have when you wake up and go to work, and which disappears. So, and this feeling, right? Just by definition of feeling, it's a subjective thing. So yes, you can pose experiment, is this thing intelligent if you put the definition, but just philosophically, just by definition of it, you will never be able to pose an experiment which proves that something is subjective, by definition of subjective, right? So it's kind of hopeless in a sense, right? But so I really like to to play with this following thought experiment. So imagine you build a robot, right? And a robot behaves as a human. So I don't know. You may even know that it's a robot. You just you can go inside, open it up, and whatever. And you apply any definition of consciousness to this robot. You say, okay, it's about quantum tubules, or it's about information. And someone measures it and finds, okay, well, this robot does not have quantum tubules, or this robot does not satisfy some information. And you ask robot, okay, robot, are you conscious? And he said, well, yes. You say, are you sure? He says, yes, I'm really sure. I'm totally conscious, right? Would you ever be able to prove to him that he is not conscious? He will say, you will say, okay, do you feel pain? He says, yes, I feel pain. Do you feel red? He says, yes, I feel red. Are you intelligent? Yes, I'm intelligent. But you see, this definition doesn't apply. And he says, well, I really don't care, but I'm conscious, right? In this sense, any definition you put forward are kind of hopeless. So in my opinion, the subjectivity part, unfortunately, doesn't seem to, I don't know the answer. Yes, I don't think it can be defined. However, all other parts like intelligence, there are a lot of people who define intelligence, for example, like that you're maximizing certain value functions, stuff like that. So There are a lot of other aspects that people do define, like pain, for example. They have a lot of correlations with that. But the subjectivity is something that I don't think you can define just by definition. Right?
Thank you. Sir Roger, would you have the last word, please?
Yes. Well, first of all, I mean, one of the problems, of course, is we don't have a good test of whether a thing is conscious or not at the moment. Well, that's part of this argument about animals. I mean, do we know whether an insect a bee is conscious or not? We don't have a good test of that, and I completely agree with that. Doesn't mean that we'll never have a good test. Maybe we will one day. However, let me address the other point you make about, okay, that chess position, you could someday make a machine that will be able to tell that that's a draw. Of course you can. You just say, hey, make a machine, if you see this position, it's a draw. Now that's easy. That's sort of a trivial answer to that problem. But it's like the whole question of the Gödel thing, you see, or how we know in mathematics something is true or not. I mean, the Gödel thing, it's just like that. You say, okay, you have a system of rules which is supposed to be something you can rely on, that if those rules say, yes, that thing is true, you believe that thing is true. You looked at the rules, you say, yes, it's fine. As long as those rules are followed, it is true. And then you say, well, look, here, this is a statement that we know that it can't be asserted to be true by the rules, but you can see because your belief in the rules tells you it is actually true. So you know it's true because of your knowledge that those rules only give you truths. It's a subtle thing, that. Now, you might say, okay, well, we'll make another one which says that particular thing is true. Fine, you know it's true because of the way you constructed it. But then you go again, you say, but it hasn't caught this one. And then you say, well, we'll put that one in too. We know that is true. But you see, this endless chain, it never stops anywhere. If you stop anywhere, you're lost because you can point out something else which defeats it. So all I'm saying is that our understanding enables you to go beyond the rules. And that's what it does. Now, of course, you might have rules that you don't understand, and then you don't know whether it's true or not. But the important thing is, how do you make these decisions as to whether it's true or not? And those decisions require our conscious understanding. And this is something in mathematics which is very clear. It's not because the rules are correctly followed. And even if it were because the rules were correctly followed, you have to convince yourself that those rules only give you truths. I mean, people often say, well, you could have a big lookup table or even an infinite one which tells you true, false, false, true, true, false, true, false. But then how do you know that lookup table is really right and is giving you the truth? That it is true when it says true, it is false when it says false. You don't know that unless you understand. You have to understand how that thing is built and that it gives you true when it says true and so on. So that's where your understanding comes in. And the understanding, it seems to me, is very clear from these arguments, is not something which is given by computational rules. And this question is not addressed by any of these arguments. I mean, sure, as you say, you could build a machine which does that one you've just given me. You see, I can say, okay, that particular chess problem. Of course. You just make it say, yeah, that one's a draw. There's no understanding in that. I mean, you put your understanding in. It hasn't got the understanding that it's a draw. I mean, that's not the right way of going because how does it know that it's a draw? And how does it get the knowledge that these things are true and that mathematical statements are true? And that knowledge has to come from your understanding. And that understanding is not a computational thing. It shows it's not. And that has to be addressed, that question. So understanding is not computational. And I don't think that when people address these arguments like the one you gave, sure, once you know it's true, you can put that into the truth bank. But that's not the point. The point is, how do you know to put it in the truth bank? You've got to use your understanding to know it's true. With chess, of course, it's a finite game, and so ultimately you could do it, ultimately by running through all possibilities. You can't do it yet, but yes, you could eventually. But in mathematics, you have things which are infinite. You can't do it that way.
Fantastic. Thank you so much. I'd like to thank the Qualcomm events team and Anya and Pat for their help, and Joan and Erwin for letting us use this wonderful venue for this event, and to these incredible geniuses that came up here and expressed all their views, and especially to Ryder, who traveled all this way. Eugene, thank you so much. Oleg, James, hope you all appreciate this. We'll have a little time now for some coffee and some dessert. And I really enjoyed it. I hope you all did. Thank you so much.